In this video, we will get our hands dirty and we will do together some textual data analysis. In the last video, we have seen many theoretical aspects of natural language processing, so I think it is the high time we get to the nitty-gritty. For this, we will use the Space News dataset. This is a dataset that includes over 20,000 news articles in English. And these news articles, as the title might give it away, are related to the space industry. Altogether, there are more than 14 million words in the dataset, which makes it really perfect to train language models and to use it in different space industry ecosystems. The dataset you will see contains the title, the URL, the content, author, published data, and so on. So first of all, what I did here is I imported, I'm using again Google Colab. So I imported the dataset in Google Colab. I uploaded it here. And the first thing I would like to do, we have two hidden cells here that I would like to see. This is the dataset, the link to the dataset if you need. I am importing the libraries for reading the CSV into a data frame. So this is a CSV file, as you can see. And then I'm printing the number of rows, the number of columns, and the header to see how the dataset looks like. So there are altogether over 20,000 rows, like I said, and there are 6 columns. And these columns are the title, the URL, the content, the author, the date when the article was published, and the post excerpt. So what can we do with this? So first of all, we are looking at if we have, for instance, none values anywhere and stuff like that. But let's start with describing the data. So how do we check the title? So for checking the title, for instance, if you want to check the title column and the first entry, you can specify like this. So you choose the first column and then you choose the first position. So the first row. And then we have electron launches first NASA pre-fire Earth since CubeSat. So you can see it over there. Then if you want to get more info about the dataset, you can call this function. And then you can see all the columns and you can see also the data types here. Now, a really important thing is to check for NaN values in the entire data frame. So if you want to count them and then print them out, you can count them in this way, and then you can display them so you see how many there are. So if we look at these results, we can see that there are 165 entries, non-entries on the content column. And then you can also see that there are over 2,500 entries on the post excerpt column. So now what we would really be interested in doing is really see the indexes of these NaN values. So in order to do that, we are looking in the content, for instance, part to see what is missing from here, right? And then print out. So here we have the indexes where we have these NaN values. So what we would like to do now is to get the contents of these missing articles. And for this, if you missed Beautiful Soup, that you have a chance to see it working again. So what we do is I actually think I imported pandas already, so that was probably completely unnecessary. We can delete it from here. But what's important to do is to import requests and then to import Beautiful Soup again. And then what we do here is we fetch the article content from a given URL because we have the URLs. So we create the response based on this URL that we are getting, and we are finding the article content. This is, you can change this based on the website structure. But essentially, we make a request based on the URL we have, and we get the text. And what we can also do is this: for every of these indices, we are getting the URL, and then we are getting the content of the article. And we print out then if the content was fetched for a specific index, so for a specific missing none value from that particular column, or we are printing out no content was found for that with that specific URL. So if we run this, then you can see that we get content fetched for this, and we get an error for another link, and so on. You have another piece of code here that I'm not going to run right now. You can play with it yourselves. It also uses beautiful soup, and it prints out where there are errors from getting the page or not. But now let's get to the cleaning data part. This just finished. So what we would like to do now is to drop the nonce from our data frame, df space news, and I would like to save it in another data frame, and this is just because I would like to keep things a little bit clean and not mix them up in case we are doing different types of operations later on. So here we see that we clean this data frame, and if we check it out now, we have left over 18,000 rows, and we have still the same 6 columns. So we have the title, the URL, the content, the author, the date, and the post excerpt. So now that we did all of this, we cleaned the data a little bit. Probably there can be many more things to clean the data, but this is just one step that you can do. Then we get to EDA, and we start with some visualizations. So you remember probably from previous lectures that EDA is all about visualizations. So first thing that we could do is to visualize the top 5 authors by the number of articles. And in order to do that, we import Seaborn and we import matplotlib. And then we plot the top 5 authors of the article. So we create essentially a histogram that looks something like this. And from this histogram, we can see that the most prolific author was Jeff Faust, who has more than 4,000 articles. Then Peter Selding, who has more than 2,000. Then Sandra Irwin, who has maybe a little bit more than 2,000. Deborah Werner, who has more than 1,000. And Caleb Henry, who has about 1,000 articles. What else could we do? The next thing we could think of based on this data set here, because there are so many articles and there are so many data points, so to say, then we can also visualize the days with the most articles. So which were the days during the period that the article was taken data from that have the most articles. So we're going to use again Seaborn to do this, and we are going to select the date from our data, so this column, and then we will order the date, and we will essentially extract the, I don't know why it was 20 here, it's actually 10. I was playing with it earlier. So we have the 10 most 10 days, top 10 days by article count, and we see that actually The date with the most articles published was October 1st, 2011, which has a whopping 175 article published. And all the others that are coming afterwards, September 26th, September 23, 2012, and 2013, and so on, have a lot less articles with that. So it would be really interesting to see what is happening on that particular day and why did we have then so many articles, like what were the articles about and so on. So then let's print the 10 articles from that day. Uh, so we take this day with the most published articles and we print, because there are 175 of them, we're not going to print all of them, obviously. So let's look at the first 10 of them. So these are the first 10 articles. So Shuttle Atlantis returns from scheduled mission, Shuttle retirement slipping in 2011, NASA packs and so on. So there are a lot of this news surrounding this Shuttle Atlantis, and then other kind of events that happened on the same day. So another thing that we would like to have is maybe the length of the article. So what we can do is to take our data frame, the new one, A, and add a new column with the length of the article. So I'm adding this new column, and we are essentially getting the length of the article for every row in this content column, which is here. So if we run this, then right. And then if we look at this info, we see that we have a new column of type integer. And if we look at the head again of A, we have the title, URL, content, author, date, and so on, and the article length. So this is what we wanted to do. Um, then it would be good to look at some article groups and see um, how the distribution of the article looks based on are there more shorter or longer articles. So in order to do this, we create a histogram again with Seaborn, and we visualize the distribution of the article length to check if there are distinct groups of articles based on their character length. So let's see. So this is what the distribution looks like. It is right skewed, as you can see. But what would be really interesting now to know is what are these longer articles about? We see that there are, well, not that many articles if we look at how many articles there are together, only 700 out of around 20,000, but or more than 700 that have quite a lot of entries. So what are these longer articles about? And in order to do that, we can print those that are have a length more than 25 thousand characters, and then we can check what the result is. So the result is the COVID news and updates of the for the global space industry. So I'm assuming that this is about how COVID-19 has impacted the global space industry. So this is not very surprising. Then there are a lot of reviews, which if we think about it, the review articles are always longer in general. If you look at review scientific articles, they're also longer than normal articles. So this is also something that is somehow expected. And now let's look at printing them, but I don't want to print maybe all of them. So if we took the first 100 entries in this data frame A, which is now our working data frame, and let's show every 10th article. So we print the article index, and then it goes like this. So this is the first article. We can see where it has been updated, where it has been published, and so on. Then the 10th article, the 20th article, the 30th, 40th, 50th, and so on. So we have, for the first 100 entries in the data frame, every 10th article, like I said. And now just so that we don't continue with, I think in A there were around or over 18,000 entries. We should create a data frame with only the title column, and we are doing this so that we process faster in the next steps, so that we don't carry the whole that table, that data frame with us. So we create a new data frame which comprises the titles of the articles. So here it is. And then let's explore this new data frame. So for this exploring, let's get the shape. So the number of columns and rows. Now we print that out. Then we access the first row. So we want to access that. Then how do we access a specific cell by row and index column? So this is like this. And then we can also iterate through rows and accessing cells, and we can print the title. But I don't want to do that because even this is essentially one column, then we still have over 18,000 entries, so I'm not really keen on it's not gonna go until 18,000. Probably it's gonna stop at a few thousand, I guess, but I don't want to wait for that long either. So I commented that part out. So yeah, like I was saying, there are over 18,000 rows, and then there is one column, the one that we selected. And then the first row is Orion splashes down to Endor Themis 1. This is not what you cannot see it there. And then this was the title of first index and column. So now one interesting thing would be to visualize the title length. So what if we plot the number of articles based on the length of the title? So we can create this histogram for this. And in order to do that, we are writing this code over here. This is very simple. And it looks something like this. So here we have the number of articles based on the title length. So there are over 6,000 articles with a title length more than 60, which is not very surprising. And you can do a lot of this kind of analysis, both with the title and with the rest of the data frame, but I'm not gonna go into everything here. You can play with this. You will find the link to the code in Moodle eventually. And it would be nice now if we actually go back to a bit of textual analysis, because this was the point of the lecture. But of course, always we have to start with EDA, with pre-processing, and so on. So next thing